Hi everyone, welcome to the latest in the ATA series of webinars on sustainable living. My name is Donna Luckman and I'm the Communications Manager at the Alternative Technology Association. You cannot see me at the moment on our webcam on the right, that's our two lot of presenters for today. But I'm just going to do a brief little introduction to the webinar series and also to our presenters. If you are joining us for the first time, the ATA webinar series continues our mission of sharing practical knowledge about energy efficiency, sustainable building and water conservation in the home. The online format makes it possible for people across the country and across the world to participate. So you can probably see that on the messages column on the right-hand side of your screen, you can write a message to anyone at any time. You can also put in questions that you'd like to give to our presenters, because we'll be having a 15-minute Q&A session at the very end as well. So start thinking about your questions now and as we go along through the presentations. Each of these webinars are recorded, and we then put them up on the ATA YouTube site, and that will take us a couple of days. But you might want to pop onto the ATA YouTube site at any time, because we have got quite a few other presentations on there as well, some on energy efficiency, some on saving water around the home, and those are on sustainable houses as well. We also like to thank Bank MECU, who are our sponsors for our webinar series. Without their support, we wouldn't be able to share the information that we're able to give to you today. So we might just get right into it. So our first presenter today is Dick Clark. Some of you might know Dick Clark has been a leader in sustainable building, and he's been practicing as a building designer for over 30 years, exclusively looking at ecologically sustainable and culturally appropriate buildings. That's a bit of a mouthful, Dick. He's the principal of a Sydney-based design studio called EnviroTexture, and he's there providing design and consulting services for people and organisations who want buildings that work well, feel good, and are culturally appropriate. He's a contributing author of the Your Home manual, which a lot of people might see, and also it's on a government website of yourhome.gov.au, which basically is a bit like the Bible of sustainable building in Australia. Dick is on the Technical Advisory Committee of the Your Home. Dick has also won over 20 design awards, and especially for his houses that look at sustainable design. And he has also won the HIA Australian Custom Built Home of the Year in 2009. So I'm going to hand it over to Dick to talk about one of the projects he's been working on.
Thanks, Donna. Good morning, everyone. I'm going to be talking about site-responsive design. Every design should be made in response to what the site demands and what the clients need. And so, briefly, I'm going to run through a series of topics that are on the screen now: locality and climate zone, and then the rules being the things that we can't change. And that starts with a site analysis to find out what it is about the site that is going to affect what we do. We can't change the laws of nature. We fight them at our peril. So it is always better to work with them. And this is the fundamental of passive design, that you work with the laws of nature. The other externality that we can't control are the planning controls from local government and state planning policies. So they're the rules, they're the externalities. And then number two, we look at the humans. So we have a design brief, and that design brief should really find out what the occupants need. It will start with what they want, and then we have to give that a bit of a shake to find out distill out of that what the real needs are. And the other factor there, and some people put this in the externalities basket, is the budget. Everybody has a budget, even Jamie Packer, I believe. So we need to identify exactly what its limits are and do whatever we can to make that work. And Rodney will doubtless have some further comments to make about that as we go on. And then number three is the design response. So having started with our site analysis, and the design brief, we then put those in front of us and say, okay, what do we now do to answer the question that they have posed? And so the design concept is produced, do some 3D modelling. The 3D modelling should tell us how buildable the structure is. We can do some studies and find out what's going on with solar access and so on. And then just to follow through with the documentation and through to the construction. And then lastly, we'll just look at the result. Now, I have to say that what happened here is the first question, which we're not going to go into in great detail, is do you renovate or rebuild? And that's really a topic probably for another webinar. But suffice to say that what the existing cottage on the site just wasn't worth spending $1 on. So we just moved straight on, and we decided that it needed to be replaced. So that's the process there, the rules, the clients, and then the design response. So if we look at the rules, these externalities that we can't change, we start with climate zone. In this case, coastal Sydney, we get summer sea breezes, we get no frost. So it's a relatively mild climate zone. So that enables us to bend a few rules that we otherwise might have to rigidly adhere to. We're looking at the topography. We've got a steep slope, it's east-facing. Solar access is available, and we are protected from westerly winds. Now, the westerlies in winter are the dry, cold winds that just tend to cut through everything, and in summer they're the hot bushfire winds. And this site is completely protected from them. So once again, we're able to bend a few rules which otherwise we would need to stick to. The southerly changes that blow up the coast, even that big east coast low that last week caused a lot of flooding and huge swells, did a lot of damage, is mitigated just because of the immediate topography. There's a little bit of the peninsula that curls around to the south of the site and protects it. And yet the nor'easter, the summer sea breeze, is right at the door. It's not completely in your face, doesn't blow the wig off your head like it does if you're on the immediate coastal sites, but it's sufficiently strong to provide really nice cooling. There's an aerial from Google Earth or Near Map or somewhere, I can't remember which. So that's the part of the Australian coast that we sit on, just north of Sydney. Zooming in on the right-hand side there, you can see Pittwater, and then zooming in again, Narrabeen Lake down to the left, you can see the beaches, and then on the right-hand side of the screen, the street from above, and finally there's our site. And there's the survey, and you can see by those contour lines just how steep it is. There are some little level patches. There's a level patch right at the top. Right down the bottom is level-ish, moderate slope, but pretty much everything in between has got quite a significant slope to it. So when we did our site analysis, we draw out the site and we look at the slope and map on the drawing there where the steepest slope is. You can see right up against the private access road that comes off the side of the actual street. That access road is there because the immediate part of that street is too steep to get driveways down off. So they ran a little road in that services half a dozen sites. And right at the top there, once you come in a few metres from that access road, it just falls away. So it's very steep, then merely steep, then it goes into moderate, and then down at the bottom, kind of almost level by comparison. And on the site analysis, we then map out where the views are, where the summer sun and the winter sun paths are, and where the breezes are. And hopefully you can see all of that. And that's something that should be done for every site before you start making any further decisions. You really need to map out what is actually working on that site and those things that you cannot control. We had that survey, so we did a digital terrain model. The buildings up near the top are the two neighbouring buildings. You can see one of them is quite large. And then there are a couple of buildings down the bottom. One of them is a garden shed and the other is a granny flat, which has since been replaced, but we're not talking about that today. So you can see there, right at the very top level, straight off the access road, and then it just falls away, and that's pretty much the story right through where we needed to put the building. So what that tells us is that if we want to get ground contact and lots of thermal mass into the building, we're going to have to spend a lot of money doing it. And one of the issues with the budget was, it had a limit. And so that was steering us towards certain decisions. So just having a look at the site, this is the old cottage before we started, and I'm up here on the main street looking down at the little access road and then through the front gate. We also had three fantastic, and still have, three fantastic ukes on the site. They're just beautiful trees and the canopies are magnificent. Like most eucalypts, the canopies are quite transparent, and so if you get up amongst it, you can actually see through it, and they don't block views, but they just provide this amazingly interesting thing to look at, apart from their biodiversity benefits. That was the house next door. It's got significant overlooking issues, so pretty much all of their windows and decks overlook our site, and we had to consider that, and that had been there for over 20 years, so there wasn't much we could do about that one. Then we look at the controls from council. We're on a slip site, so we've got some issues we had to deal with in terms of the hazard there. Acid sulphate soil, that one didn't worry us too much. Landscape Category 3 requirements, that speaks about what your landscape design has to be and certain characteristics that it has to incorporate. We had to have on-site stormwater detention because immediately below the site is the North Narrabeen or Narrabeen Lagoon flood basin, and it floods. And so what they're trying to do is stop runoff from entering that, and so we had to store it on site. But Pittwater Council, in their wisdom, and I mean that literally, I'm not being sarcastic, has said, okay, if you put in a lot of rainwater harvesting, you can trade off some of your OSD requirements, and you'll see later on how we did that. We had an 8.5 metre height limit and side setbacks of 2.5 metres on one side and 1 metre on the other. Driveway level limits, but we had to provide 2 car spaces behind the front building line. Now, a little sketch down there shows the maximum allowable slope that you can get your driveway. And because we knew we had to have the garage right up at the top of the site, and yet we could only get down by, I don't know if you can see that number, but scribbled in on the right-hand side there is a number that says 730. So our garage could only be a maximum of 730 millimetres below the access road. And so that immediately informs the rest of the design of where the garage is going to be, and if, as this design brief called for, we want level access so that aged visitors and so on aren't going up and down stairs when they're on the upper living level, then that then pretty much controls where your upper living level is going to be. So, everything's connected to everything else. We also had building envelope issues. You'll see that later on, and maximum site coverage of 50%. So those are what council said. Now, this is a little spoiler because this is using a section through the building that we ultimately designed and modelled. So it's really there just to kind of show you what the slope was doing. 40% up near the top of the site, 18.5% through where most of the house is, and a 23.2% average. And then up at the top, you can see the 2 height planes. 8.5 metres is their notional limit, but on steep sites, it will allow you to go through up to 10 metres. And it's not a given that you'll get approval to do that. So we had to justify where we went through it with some of our roof planes. Then we go to the design brief, and if you haven't thought through a design brief, then it's really important that you make this a very deliberate and well thought out process. Their design brief is summarised here. You can see a little grab of the PDF there on the right, but summarised as a sustainable home, so passive solar design, especially winter sun. And Rodney, not altogether facetiously, said, I want to be able to wander around in boxer shorts in the middle of winter. He may say something about that later on. We wanted the building to be visible in the materials used so that the materials were honest to what was going on. They wanted a treehouse feel and a connectedness with the trees and the landscape. Now, Barbara is a landscape architect, and so we were able to do some interesting stuff there. To have a flow from the kitchen to the lounge and to the pool and courtyard area, and then to have views and a coastal connection. Now that is a summary of something we spelled out in more detail, but the building should look like it belongs on the northern beaches of Sydney. It shouldn't look like it belongs in another landscape or another context. Should have PV, meaning photovoltaic, solar power, solar hot water and rainwater tanks. Needed to be integrated into the landscape design, and then with a separate granny flat to be rentable at some point. And then as we moved through, it became clear that we were going to be dealing with an owner-builder here. We got some preliminary price checks, and Rodney decided that he wanted to work with the 20% that he would save by going owner-builder rather than working with a builder. And so we needed to think that through as well. Now, the budget was $600,000 to start with, and we needed to guard for overruns. Then the design response, the concepts, well, what we were thinking, it was too steep and too slippery for ground contact. So that traditional mantra of passive solar design, having lots of thermal mass that is in contact with the ground, really wasn't going to work for us. The budget would not allow it. But the coastal microclimate didn't demand it anyway. We had a whole lot of mitigating things here that meant we could actually depart from that to some extent. We also had to fit our spaces into various levels below the 8.5 metre height. The cars had to be at the top. It was the inaccessible option. We were able then to say, well, let's do a concrete slab floor for the garage and use the space underneath for water tanks. Different ways of doing that. In the end, we opted for freestanding poly tanks. There was a priority in the brief for family spaces on the upper levels and a granny flat at the lowest level. So they were where we started pushing the arrangement of spaces. So if we go to the 7 elements of passive design, and it's easy to remember the 7 elements, you just count them on your fingers. If you haven't got enough fingers, go for a swim through a nuclear waste dump, you'll soon grow some. So orientation, thermal mass, zoning of spaces, insulation, ventilation, shading and glazing. So those are the 7 things that we still had to incorporate, always have to incorporate into the design. But the thermal mass was going to be a thing that we couldn't really do in a conventional way. Now this is a sketch taken from the Your Home manual, and it shows the principles of what ground coupling gives you, in that it gives you this massive amount of thermal flywheel, if you like, the ability to regulate warmth and cool. So if we couldn't do that, how were we going to do it? And the other constraint we had then was the driveway. You can see the levels there that we were able to squeeze from Pittwater Council's maximum low, is what they call it, a maximum low driveway profile. So we had to spell out all of those levels to say, well, from the road to the garage, that's what we can do. So that set a number of things. And when we started sketching around things, in our process here, we said, okay, well, it looks from the outset like we're going to have 3 levels. Top level, the brief says we want lounge, meals, kitchen to be in one space, and the deck directly connected that to another space, and then these are the other spaces that we need on that level. And we just started sketching around arrangement of spaces and putting things where they needed to be in relation to north, knowing that the saving grace of this steep east-facing site was that we had good solar access. The common element there you can see is the stairs, so sort of follow that through. So we have then the arrangements on the lower levels, that's the mid-level of the bedrooms, and then down at the bottom level we've got the granny flat. And then we started thinking about how that might sit on the site. Now north is off at an angle like that. We followed the north orientation fairly precisely. And the hill to the west curtails the winter solar heating hours, and that was one of the reasons for following north precisely, that the mid-afternoon, or just after mid-afternoon in winter, the sun starts to dip down below the hill. So we needed to pick up what we could in the morning and midday. It also gave us better views to the surf and the headlands, and it provided some articulation to separate us from the neighbours and give us some deep recesses to get some significant planting, while still maintaining their solar access. And it also meant that we could optimise our PV output once the solar panels went on the roof. So that's the sketch from the street up here, garage. That's basically the orientation, and we stuck to that reasonably closely in the end. And then the floor levels went through. So we originally said, oh, well, look, we're going to need some stairs here if we're going to drop this down, and that will get us compliance. But Rodney and Barbara both said, no, that's not going to work for us. If our parents come to visit, we don't want them tripping up and down stairs. We really want this up at the higher level. And so we pushed that argument with council, and they agreed. So that was nice. We got rid of those stairs in the end. The mid-level with the bedrooms, the final design is actually pretty close to that concept, and then the granny flat at the bottom. We also needed to think about the buildability of it. So even at that early stage, I was sketching out pier, bearer and joist layouts to look for the optimal solution. And we had a bit of an argument with the structural engineer who wanted to do massive piers and lots of steel, and we were saying, no. We need to optimise the piers, reduce the number because they're expensive, and just make them do more work, and get the really most efficient structure in there that we can. And we ended up winning that argument. I think we got a pretty good result from that point of view. So once we get to the concept stages, we then can 3D model it, and this is where you now start to see some of those site responses actually take flesh. So you can see how the building has departed from the site. We haven't got ground coupling, and we needed to find a way of boosting the passive solar because there's no material in the core of the building here that will store warmth or coof. Now, so far as the coof goes, that is the ability to stay cool on a hot summer day. Because it's immediate coastal and the nor'easter is right there, most of our cooling is always going to be provided by the sea breeze. So we didn't really need thermal mass for cooling, but we do need it for solar heating, for passive solar heating. So we still needed to come up with a workaround for that. That's sort of from the northwest. You can see there's a shade sail that will be put across there to protect this corner, but there's a lovely big glazed gallery on the entrance, lots of solar panels on the roof. Gav, can you run that first June movie? So here we go. I'm not sure if I'm going to be able to run that one again. Can I? Yes, I can, and pause it. So this is actually not the June movie. This is the summer. This is the February movie. Never mind. Ignore it says June down the bottom. This is February. So imagine the early morning summer sun. Oh no, here we go. This is June. Thank you. So here we go. This is the June sun, and you can see how the sun in June has got penetration right through the day. So what we are looking at in this movie is it's as if we are the sun looking down at the building. And let's see if we can get that back to the beginning. Okay, so as the sun moves through the sky during the day, it's looking at that building right up until the point now where it sets over the western hill. And then that's theoretical sunset, but of course it leaves the building at about here, somewhere about there. That's it's gone on a little bit. Anyway, hopefully you get the idea that using these 3D models, we can actually check to see how much solar access we're getting, and see exactly what's going on. Let that run through again. So then the next movie is the February movie, which is the summer condition. It's interesting. It's actually been mislabeled on the movie up top there, so that's probably my mistake. But anyway, this is definitely February, the early summer morning. You can see it's looking at the eastern side of the building, but as it climbs through the sky, it disappears behind the shading. Let's run that again. so that we can check to see if there's any point that we're getting too much sun in. And you'll know, of course, that the summer solstice is December 21, 22, but in fact, the worst case for Sydney is always the 20th of February or thereabouts, because that's a hotter month than December, and yet the sun has actually started falling from its zenith slightly. So it's always good to check that February works really well, much more so than the summer solstice. Just once more. So that's very briefly the 3D modelling. And from that 3D modelling, let's put that away. From that 3D modelling, you also get very accurate plans and elevations and so on, so you can see in fine detail what's going on. And once again, at every point you need to check back to your site analysis, check back to your design brief, evaluate at all points what's happening. And if you want to make changes, that's fine, but you need to do them intelligently and not without thinking. And so having established that kind of discipline in your design process, that will always make sure that you are doing things, you know, in a way that is in control and not without thinking. And then as you move through the documentation, you need to make sure that things don't get away as well. And one of the things we are very, very careful about is the glazing. And this is an area that, along with the insulation, builders seem to get wrong a lot. And so it was great working with Rodney as an owner builder. He would always come back and ask, I wish builders would do that. And I have to say at this point also that Rodney was dealing with a very severe La Nina season for Sydney. So he had one of the wettest building periods that you could inflict on anybody, and he came through it brilliantly. It does mean that there are a couple of external details that still haven't quite finished, but that's just because it's rained so much they haven't been able to get to it. But one thing I would suggest you always look at is the glazing. It is the weakest element of the building envelope, and yet it's so very, very important. When I say the weakest, it has the lowest insulation value by definition. Even high-performance glass is not as well insulated as a wall, so it's very important you get that right. So we always make sure that that's very well documented. And now we can have a quick look at some of the photos. So if you see a few little loose ends around the outside that aren't quite finished, spare a thought for Rodney, who's just been battling with unending rain. You can see the articulation in the building. Some of these photos were taken a couple of months ago, some just the other day. And that material on the front there is actually a recycled hardwood pre-weathered, which is a nice sustainable kind of material. A lot of colour bond and WeatherTex weatherboards on the building. And we've got this nice no-post corner. That's a response to the design brief to get that big flow of space from inside to outside. And here you can see the rain between showers and the view to the coast. So that's in response to the design brief. That smoke in the background was a large factory fire at North Narrabeen the other day. You may have seen on the news. That rather buggered up our views, unfortunately, but there you go. So a couple of photos of that beam and the detailing onto the post, and the view through to the trees and that kind of treehouse feel. So that's a response to the site. If those features are on the site, then those are the things that we need to respond to. From the lounge dining area, looking out to the deck. This is the granny flat down on the right. This is the granny flat at the very lowest level. And even down there, we made sure that we had this, took advantage of this little window of solar access so that it gets passive solar, and it is a slab on ground down there. So that was the point where we were able to re-establish ground contact. So it's a classic passive solar construction down there. And the rest of the house up here on the left the main lounge dining area. Beautiful solar access, but of course there's nothing in there that we can really store the heat with. And so we used hydronic heating as a kind of de facto means of getting heat into the building, because there's no thermal mass. In terms of zoning spaces, things like sliding doors to lock off different parts of the building in winter, and they would remain normally open in summer. So our de facto thermal mass is provided by the hydronic system. This one was designed and installed by Rotex, and with a little bit of pushing from me, we got them to clip it directly under the floors rather than using their whiz-bang proprietary system that sits on top of the floors. It was cheaper to do it this way, and we didn't need the performance that that system provided. So we were able to save a bit of money and still get a good result. That's the little controller there and the big tank. And of course that subfloor space is totally insulated. There's the foil board between floor joists. The floor joists in this case are I-beams, so the foil board can sit on top of the bottom web of the beam. And then the insulation in the walls and roof is critically important. And it will be subtly different. So if you had a site that was in Western Sydney or at the foot of the Blue Mountains or Southern Highlands or in Victoria, the insulation regime will be subtly different as you move away from the coast and change altitude and latitude. Ventilation, we've got this window down in the mid-floor. This is between bedrooms, so that introduces light deep into the floor space, but also a small window. It's only single glazed, but it's massive ventilation space. So we use louvers in isolated places in the more coastal sites, not further inland or further south. The kitchen window is a sliding window, so you get quite a big opening. That's all double glazed, thermally broken frames. And then the ceiling fan, of course, sneaks through as kind of a cheating way of increasing your passive cooling. In fact, it's not passive at all. It's a mechanised system, but there's such low energy that it sneaks through. Shading, once again, just look at those two slides and a reminder of those two movies to check that it works. And then the glazing, double glazing, argon filled, but the glass in this case is standard clear toughened glass. We didn't use low E for budgetary reasons. We didn't need to use anything that stopped solar gain because our shading does that. So this is the cheapest high-performance glazing where you get a nice relationship between the glass and your external shading. So the shading takes care of summer and the glass takes care of winter. And then this black strip you can see down the door is the structural polymer that joins the two halves of the extrusion. That's the thermal break. So this is quite a new style of window and door frame for Australia. Several manufacturers have them. I think this one was from AWS or Vantage. Others include Rylock and Trend. The solar power and PV for the building, you can see the PV system there, and then here is the evacuated tubes to provide the domestic hot water and hydronic heating, which is our de facto passive solar. And once again, those sun studies that we did very early on proved to us that we had sufficient roof area in sufficient sunlight to make that work. Now, acoustics, this isn't necessarily seen as a sustainability issue, but I think it is. Might be a bit fringe, but if you have a open plan kitchen, living, meals area, one of the things with hard surfaces, you get a very percussive and live, acoustically live space. And so it's good to, in the ceiling, to take planes out of parallel so that they're not quite so reflective, and to break it up with shape or texture. So factor that into your thinking. It's always well worthwhile. The lighting, in this case, it's all LED. There are a couple of compact fluoros externally, but essentially the whole house is lit with LEDs, and we've really moved on from compact fluoros. LEDs are where it's at now, so far as we're concerned, because they're just so good. But, sorry, I'll just go back one slide. The first thing to get right is always daylighting, which is what this slide is telling us. You know, there's a deep floor space here. We've got a north-facing window to get deep light into that. It's most important. Water, we don't do wastewater treatment on this site. We're going to have issues with council if we tried that one. So instead, we put all our eggs in the harvesting basket. We've got 72,000 litres harvested with inlet filters, screening on the gutters, and then inlet filters on the way into the tanks there. And of course, on the demand side, efficient water shower heads and taps and so on. Waiting. Look, maybe that's our last slide. It doesn't want to move on any further.
All right. Well, thanks for that, Dick. That was fantastic. And what I'll just remind people now is that you can actually send a message to Dick if you want, if you've got any questions from that presentation. So if you go down to the box in the right-hand corner under messages, put in your message in there, and it will be saying send to everyone, and click that little arrow, and then your message will be able to come through to us. I'm just going to introduce now our two homeowners, Rodney and Barbara. Rodney and Barbara are originally from the UK, but they have lived in Australia for over 14 years. Barbara is a landscape architect, and Rodney is a sales executive and a secret veggie patch master, and also a general handyman. So sounds like someone you want around when you're doing a renovation. They also have two kids who are aged 4 and 1. They bought their northeast facing block in 2003, loving the location, which is close to beach, shops and transport, and of course those beautiful gum trees that Dick showed us earlier. They were looking to rebuild. They wanted to do passive solar design, and they were lucky to find out that Dick and his Envirotecture design were based up the hill from their house. So I'm just going to hand it over to Rodney and Barbara to just talk a little bit what it's like to be living in their house.
Good morning, everybody.
Hello.
So basically, as you can see from the picture there, our house, and you can see basically we still have a bit of painting to finish. We'd originally bought in 2003. It was a Darrow block. It was full of weeds and bamboo. We did like the location and the aspect, and it's, as Dick mentioned earlier, it's protected from the southerlies. So very often in the winter, we can go and stand in the garden and be in shorts and t-shirt, and you only need to go up to the top of the hill where Dick's office is, and it's freezing cold. It was a very old post-war makeshift house, quite a lot of fibre in there, which really we didn't even want to go there with the renovation, given the health issues. And basically, living here for so long allowed us to understand how the block functioned in all the seasons, which is why we were able to give Dick a very specific design brief as to what we actually wanted. Also, over the years, with Barbara being a landscape architecture and me, as Dick liked to call her, what was it, a veggie patch guru. We basically spent a lot of time, ripped out all the bamboo and the weeds, and created a fantastic native garden with the veggie patches down the bottom. What we like about the house, I think the number one thing about the house is the hot water heating system from a company called Rotex, which has gone pretty well. Dick had mentioned it does the hot water and the underfloor heating, but what I actually liked about it was it also actually does the pool as well, which has basically saved us a little bit of money in allowing us to not have to get the solar heating for the pool. Winter temperature is fantastic. I mean, here we are now sat in the middle of winter. We have the doors open behind us. We actually do have the building site next door. I'm hoping that too much of the work that they're doing. But the heating's been so good that we've actually been able to turn it off a lot of the time. It maintains a constant temperature between 19 and 21. And I haven't seen any bills yet, but I'm hoping that it's not going to be too expensive to maintain that temperature. The sliding door that Dick spoke about earlier on, the one on the entranceway, that basically mentioned that in winter you would use it to obviously keep the main living area warm, has been fantastic. It was a little bit painful on the budget to actually have to put that in, being such a large, oversized door, but the heating benefits now have just been fantastic during the winter. Again, just with the large deck and the open plan faces north, so again we've been able to go outside on the deck area there in the middle of winter. The sun shines out; it's nice. It's even nicer with for the kids as well. Dick had mentioned about the location of the garage. The garage is great because it's only located about 4 meters away from the kitchen. And over the years of bringing shopping in and having to sometimes look at as far as 30, 40 meters with two big handfuls of shopping, to only now have to carry it 4 meters is great. It's unusual to say that they're looking forward to getting the utility bills, but it is going to be interesting when we do get them to see what we will actually save in the gas and the electric and the water as well. Certainly hoping that those will be minimal and will be more supply charges only. Dick had also mentioned about own a building now, and it being a La Nina year, or La Nina few years I should say. I had a lot of issues on the site with water, own a building, and I'm very pleased that I did own a build on the site because it allowed me to tackle the problems that we had with water early on. Around around the rainwater slab, and then also around the slab that sits at the bottom of the granny flat, allowed me to put proper dish drains in there, and then hook those dish drains up directly to the stormwater pipes, which has really assisted in reducing the amount of runoff that we used to have on here. Literally, the property next door, last week we just had a lot of rain, and it was just a sheet of water moving down the property. Our property actually sits in well, you could see from the survey slide that Dick showed earlier. Our property is actually smack bang in the middle of an old river creek, or old creek bed, I should say. Now, with regards to the budget, Dick had mentioned on there that it was a 600K budget. I think originally when we started with that budget, it was just to get it to a livable state, not necessarily all bathrooms finished. And we were, I think, discussed and even an eBay $1 kitchen at one point during the budget. And we decided not to go down that path, so our budget did go over probably by 20 or maybe 30% more than that to get to the finished house. But that allowed us basically to put in the commercial aluminium thermally broken windows, the bamboo, and we've got cork floors, and finish the kitchen properly. As well as, instead of having a pebble treated pool, we decided based on the costs and because it's such a small pool, being only 25,000 litres, we actually tiled our entire pool as well. More specifically for that was so that we could actually get avoid having either a chlorine pool or a saltwater pool, and actually went for an ionized pool using the copper and silver ionization system. So that's really all I have to say, unless there's any other questions. Unless there's questions.
Thanks, Rodney, and thanks, Barbara, as well. And it's lovely to actually look at you in the house and see that beautiful balcony in the backyard. Just got a few questions that have come through. This one probably will be for Dick. Dick, we've got a question from Darren who wants to know, Does an impervious insulation board like foil board cause any condensation or moisture issues when used as floor insulation?
Ooh, hot topic of discussion at the moment, this one. And a few articles in Sanctuary and other forums about it, and more to follow. Look, impervious foil insulation can cause condensation issues, especially if it's just a sheet of foil. Foil board and other composites have the advantage of having the foam as a core, which keeps the inward-facing foil a little warmer. Now, the foil board that we're using in the floor isn't all that thick, and if it was in a high heat load situation with a lot of a big discrepancy between internal and external temperatures, then it could conceivably create a problem. But in this case, because A, it's very coastal, so the temperature differential's not terribly great, and B, because it's in the floor, combined with, point C, highly vapour permeable walls, we will have no problems with that floor. Now, I make that point about the walls because buildings usually can't have vapour permeable floors because you have to assume that a lot of the time they're going to be sitting on ground. Roofs are not vapour permeable by definition of the roofing materials, and that leaves us looking at the walls to get a vapour balance happening. If we don't get a vapour balance happening, then no matter what you do, you'll get condensation, and you certainly get a very toxic indoor atmosphere. So two things need to happen. You need to open your windows and doors for simple air exchange, even in winter, for a short period every few days at most, but that isn't going to stop condensation forming. So you still need the walls to be vapour permeable. And in Rodney and Barbara's case, we've used plasterboard, which is vapour permeable, bulk insulation, vapour permeable, through a WeatherTex cavity cladding system, which is vapour permeable. And what that means is it's that WeatherTex make along with some other manufacturers, they make a woven building fabric, which you can actually put to your mouth and breathe through, and yet it is waterproof. And it's fixed to the outside of the wall frame. And then a spacer batten is placed, only 9 mil thick, up each stud, and then the weatherboards are placed on top of that. So you get a cavity between the weatherboards and the vapour barrier. The vapour membrane, not barrier. And so that allows the walls to be the constant background channel for the vapour to balance between internal and external. And usually, apart from extreme La Nina events, usually there's more humidity inside the building than outside. So it's usually flowing from inside to outside.
Cool, yeah, thanks for that, Dick. It is a bit of a hot issue at the moment, and we have had some articles on it, as Dick mentioned, in Sanctuary magazine. So when we put this webinar up, I think we'll put up a link as well to that article so people might have a read of that further too. Another question here. How do the LEDs go with raked cathedral ceilings with respect to light output? Shall I throw that to you first, Dick, and then Rodney, you might want to comment on that too.
Yeah, okay. We did a lot of research, Rodney and us together, and Rodney, very dynamic. I'm actually hoping to coax him out of being a sales executive and talk him into being a builder, because he did better than a lot of builders we know. But he did a lot of very active research on lighting, and between us, we actually in the last 6 months dug up 3 or 4 really good lights. And what it boils down to is you have to look at the lumens output, and lumens per watt is the efficiency, but the efficacy is what this question is really getting at. How much light is delivered to floor level if it's up on a raked ceiling, and you've got to really look at each light and look at its characteristics and the data that should be published with it by the manufacturer. And for rooms like this, if you don't have light output of greater than 500 lumens, then don't even bother. And usually you're looking at 750 to 900 as a workable number of lumens. But that needs to be quoted at a certain distance from the light, not just at the diode, obviously. So typically, if you're looking at 750 to 900 lumens at 2 metres, you're looking at a light that is really good for a higher ceiling.
You got anything else to add, Rodney?
Oh, no, not really. I originally wasn't going to go with the LED lights based on the cost of them, but then having then kind of done my sums with that, I think that the LED lights, I'll be ahead after about maybe 4 years, and just the fact that I don't have to change any more light bulbs ever is fantastic, because as we all know, the halogen bulbs just seem to go all the time. But in terms of lights, Barbara seems to think it's too bright in here. I was just having a quick count of how many LED lights we put in here, and I think they go up to 18 watts, and I think we've got 20 of them on the top floor. And it really is quite nice and bright, so you can select whatever lights you want at any time. And putting them on dimmers as well gives you a great amount of options also.
Cool, thank you. I've got another question here from Gary. What do you think of the green energy bricks and SIP for floor and ceiling? I'm not quite sure what that acronym is, but Dick, do you know what that one is?
Yeah, the green energy bricks are a jumbo mega Lego style block that they just look like giant Lego blocks with little studs on top and holes underneath, and you click them together that way. They're extremely high insulation value, and they're skinned on either side with a very finely machined, beautifully finished magnesium oxide board, which is quite a low energy product. So they're a great material, and we're doing our first project with it up in the Blue Mountains. Fantastic in colder climates. So what do I think of them? I think in the right situation, they're great. The SIPs, the structurally insulated panels, once again, there was a story in Sanctuary about that, and I think there have been a couple of houses built with SIPs showcased there. They're also, I think, one of the materials that we're going to use a lot more in the future, and I think that they're great. They have a lot of benefits, so thumbs up.
Cool, thank you. I've just got a question I was going to throw in, and it's probably both for Dick and Rodney. Just with the swimming pool and its placement, was that placed there for a particular reason for cooling as well, and how has that worked? At
the risk of jumping in too much, not really in terms of cooling. There's a bit of a mantra that gets around the place that says if you can get a breeze to blow over a swimming pool, you'll get cooling off it, but that's not really effective unless you've got a pool that really is a small lake. A pool this size isn't going to provide any significant cooling from air moving over the top of it. In fact, it'll be immeasurably small. It was really put in that location to be in a protected sunny spot to maximise its natural heating from direct solar gain, and to give the kids and Rodney and Barbara a nice little kind of sunny, sheltered corner to sit in that kept them warm in the shoulder seasons.
Sorry, Dick. I was just going to say, just with the pool though as well, because we've got the automatic pool cover that goes over the top of it, and then the north aspect. I'm hopeful that without having to put any additional heating on the pool, that we'll get to swim in it, pretty much for 10 months of the year, which is quite good going. And then the only other option that we had for the location of the pool was in the back garden, and where it's located at the moment is in a north-facing position. If we put it into the garden, it would be in a southeast-facing position. We would never use the pool. Not to mention, to put a pool in that location would have disrupted many of the the eucalyptus tree roots as well. So it made a lot of sense to actually incorporate that in the building. And again, as Dick said, so you can see the pool from the kitchen, and the kids can play in the pool while you can actually be in the kitchen as well.
Well, thanks, Rodney. And I might throw the next question to you as well. Do you have any figures on what was the total cost per square metre of that?
If I actually knew how many square metres the house was, yes. But do you know how many square metres it is, Dick?
I'm just about to work it out.
So, I think it's about 250, but I've never really looked at that, to be honest.
Thanks. Well, we might get back to Ross on that one.
But I think if it's based on 250, it was about 3,000 a metre.
Cool. Thank you.
If I'm basing that on 250, but it really depends on whether you start to include decking areas with that as well, because once you start to include decking areas, I think it puts it up to more like 300 and something square metres, which obviously then makes it considerably, considerably less again.
I mean, the standard way of measuring it is just gross internal floor area.
Yeah, but I would say between 2,500 and 3,000 per square metre. But I haven't done my final sums yet.
Thanks, Rodney.
No,
we just also got another general question from Judith. How about aerated concrete as a sustainable building material in Australia? Is further insulation required? Might be another one for you, Dick.
Okay, that's basically Hegel, autoclaved aerated concrete available in Australia. It's aerated concrete. It's the little bubbles of nothing that make it really something, to borrow a line from an old chocolate bar ad. And it's a relatively low embodied energy concrete as far as concrete goes. So it involves some cement, which has reasonably high embodied energy, and it's autoclaved, which is a bit more energy again, but very efficient form of curing energy. So yeah, look, it's great, and it's vapour permeable. It's produced in Summersby on the New South Wales Central Coast, so if you're looking, nothing too bad, but it probably isn't, in my opinion. I think until we get a much better rail freight system going, it's not the sort of thing that you'd want to cart across the country. Yeah, and it, like all materials, it needs to be designed, detailed and built to its strengths to avoid its weaknesses. There are members of the building industry who don't like it because they're convinced that it cracks, and yet they're blind to all of the problems that every other building system has. Every system has its faults, and if you design to its strengths and avoid its faults, then you'll have no problems at all.
Great, thanks, Dick. Well, I might just throw in just one final question to Rodney and Barbara and just ask them, what's the favourite aspect of the house that they love the most? Do they have a favourite room or favourite part of the balcony? What's their favourite bit?
We haven't actually been in some of the rooms properly yet because I've still got a bit of painting to finish. But we spent a lot of time now up on this upper level, and I think you can probably see I'm actually sat in the sun here at the moment. I'm actually baking hot. So it's the middle of June, which is the middle of winter, and it's a pleasant day. So I would say for me that my favourite aspect is exactly sat where I am right now. In the summer, though, I would probably say it'll swing towards the pool. Just a favourite aspect, Barbara?
Yeah, I think we both like the view in the bedroom, in the master bedroom. We look out at the red gum in the garden, and the sun comes up, and you just see the silhouette. So that's pretty good. And the entrance hall is lovely. The floodlit sort of entrance hall by the pool is a really nice place too. So yeah, we've only been in 5-6 weeks, is it now, or something? So still bonding, I suppose.
Great, thank you. And yeah, it looks pretty nice sitting there as well as coming from a cold Melbourne. I'd just like to say thank you to our presenters, to Dick, Rodney and Barbara, for sharing their knowledge and their experience with us today. As I mentioned, this webinar will be up on the ATA YouTube site in a couple of days' time, so stay tuned for that one. And you can also check out some of the other webinars we've had before in the past too. If you'd like more information on sustainable building designs or energy efficiency or even water conservation, you can find more on the ATA website, which is www.ata.org.au, and also in our two publications, Sanctuary and Renew magazines. We also need to thank Bank MECU, who have been supporting this webinar series. If you have not heard of them before, Bank MECU has a strong policy of responsible investment, promotion of community and involvement in sustainability initiatives. They also, with their home loans, have options for having a pause if you're doing some sustainable initiatives in your own home. That's all up for us today. Thank you for everyone for participating, and we'll see you next time. Thank you.